bigger group photo after the webinar. So yeah, back to you, Mabel.
All right, so thank you, Sir H. So next up, we have the launching of the Safe and Resilient Sustainable Webinar Series. Okay, so we'll start off this series with our first webinar, which is entitled Engineering Measures for Minimizing COVID-19 Transmissions in Buildings. It will be, we have with us our assistant professor from the Institute of Civil Engineering, Engineer Joshua C. Agar, to give us his talk on COVID-19 transmissions. Sir?
Good morning, Mambel. Thank you po for that introduction. Good morning, everyone. I'm Joshua C. Agar. Let me just share my screen po. Okay lang po. Okay. So I'll be for today, I'll be delivering a talk titled Engineering Measures for Minimizing COVID-19 Transmission in Buildings. We have to take note na even though we're engineers, we're part of public health, in tackling yung public health. Especially we have the public health crisis in the form of the COVID-19 pandemic. We have to take note that there are two main types of expertise for COVID-19. There's this clinical expertise, once the virus enters the body, how the symptoms emerge, how to treat them, how to vaccinate, for example, improve our immunity. Whereas there's also the physical expertise. So if the virus is out there being transmitted, how it travels across the air. Of course, those who knew the mechanisms of transmissions will have the expert advice. Since we know the mechanisms of transmission, we can do preventive measures such as masks, filters, ventilation systems, and UV light systems. So, of course, in a broader perspective, we'll be also upgrading our industry standards and some technical regulations to further mitigate the spread of COVID-19. Our expertise right now is needed in the concept of COVID-19 being airborne. So with regards to the mechanisms of transmission, previously, Dr. Tedros has previously declared that COVID-19 is airborne. However, he redacted it. He clarified that it's through droplets. So it kind of reflects to the dominating dogma over the past century on how these respiratory diseases are being transmitted. So this is actually an assertion by a public health expert, Charles Chapin, back in 1912. He just asserted that it cannot be in the air, it has to be droplets, despite no physical demonstrations on how these droplets are infecting people. And back in the theory is mainly being tested in the SARS epidemic back in 2002 to 2004. There was this one super spreader event. This is Amoy Gardens in is near Kowloon in Hong Kong, where if respiratory diseases are really transmitted through droplets, so basically you have to distance yourself away from the range of those supposedly ballistic droplets that act as projectiles. However, the transmissions happen from one building to another. There's an index case in this building here, but it traveled almost 60 meters towards the adjacent building, so infecting other people. The one who gave the explanation as to why this happened is Dr. Hugo Lee, who is a professor in mechanical engineering in the University of Hong Kong. So he's an engineer, but through his efforts, the acknowledgement of the mechanisms of transmission, particularly on SARS-CoV-1 being airborne, measures such as ventilation are being implemented. And eventually, even without the vaccines, the SARS epidemic was parang they managed to eliminate the threat of the SARS epidemic. And as part of his efforts, he was conferred an honorary degree in public health in the same university. And he's currently one of the members of the COVID-19 IPC of World Health Organization. So even though he's a mechanical engineer or an engineer in general, he he has managed to contribute immensely in public health. So, of course, not only in public health, but also in aerosol science, he was regarded as one of the great contributors in the field. However, after the epidemic in 2003 and 2004, somehow when it came to SARS-CoV-2, which brought the COVID-19 pandemic with the assertion of droplet, aerosol scientists have been questioning, is it really droplet? So they compiled a total of 10 scientific reasons as to why COVID-19 is supposed to be airborne. So there are overwhelming evidences such as super spreader events, which can be only explainable if the mechanisms of transmission is airborne. The transmission can occur between adjacent rooms despite droplet precautions. For example, if you're wearing face masks or face shields or hazmats, healthcare workers are still be getting infected. They tested the mechanisms of transmission on ferrets, and actually, again, it all boils down that there hasn't been a direct demonstration as to why droplets are causing the infection, where in reality, it is actually those droplet transmissions are what's called short-range aerosol transmission. One of the authors of the said paper actually presented previously in the University of the Philippines, Professor Jose Luis Jimenez, who detailed the science and history behind respiratory diseases being airborne, and also devised some of the schemes on how to impose measures to protect people against the said disease. And one of the highlights of this presentation is on surfaces. So basically said in this presentation that the what's called the hygiene theater, where you get obsessed in disinfecting the surfaces every time a customer comes in or a customer comes out, or if in the office, you have that tendency to disinfect your surfaces. It's actually minor at best. And the CDC is actually estimated that there is only 1 out of 10,000 chance that this is happening. And in reality, if you review the mechanisms of transmission on why this why infection happen on touching surfaces, you're actually applying friction on those surfaces, causing some of the deposited SARS-CoV-2 to be aerosolized and be reintroduced into the air. So basically, it's another form of airborne transmissions. And that actually represents the paradigm shift, because if you recall what's happening in the Philippines, since they are insistent of the droplets, you may notice that all of the responsibility lies on the individual. You do this, you put on face shields, you put on barriers, do that. So all of the responsibility is within the individual. But if you acknowledge that it's airborne, institutions, governments, and companies, even as engineers, have to do something about it. And our role as engineers is basically to communicate the physical effects that are observed in disease transmissions are actually consistent across different phenomena and applications. So for example, there's a river bend. So this is Marikina River, for example. If there's a river bend, there's a portion of the river, section of the river, where velocity is relatively faster than the inward bend of the river. So on regions where flow velocity is higher, you may notice that there's a higher rate of erosion, but there are no deposits there. So basically, what you're observing there is more of a rocky formation, whereas on the relative still portions of the river, you may notice that it's quite silty. So if applied to the mechanisms of transmission for virus, for example, if you want to ventilate a room, you may notice that, of course, those on the parts where the airflow is relatively higher, you may notice that the pathogens are more flushed out when compared to the center of the room where the air is relatively still. You may notice that the concentration is relatively higher. And that also applies to the different aerodynamic phenomena such as return and vortex effect. This explains as to why contraptions such as face shields and barriers are not actually contributing to the mitigation of the spread, but rather increases the risk. So it allows room for accumulation of the aerosols in the region between the face and the face shield. Same goes with the barriers, which of course is verified by numerous simulations and even clinical studies even back in 2014. Actually, the public health has been calling us engineers to step up and involve ourselves in the pandemic response. So this is a presentation by Professor Tricia Greenhalgh from the University of Oxford, calling us engineers to consider the flaws that have been unraveled during the COVID-19 pandemic. So how we design, manage, and operate the building. So if they are left unchecked, they will disrupt the management and of these and the other pandemics. Of course, it will incur high financial and health costs to the society. And of course, it will constrain our ability to address other challenges such as climate change, as what she said in her presentation. So before we delve on in addressing the risk, we have to take note that there are two main modes of transmission. But in this slide, we'll be dealing with what's called close proximity transmissions. So mainly they are further branched out into two. So sporadic emissions coming from sporadic events such as coughs or sneezes, where the aerosols are being projected forward. So these aerosols have forward momentum. Whereas if we mention non-sporadic events, for example, breathing, the aerosols don't have much of momentum, but the same principle applies for both of them. As you are closer to the source, the higher the risk that will be exposed. So it's a function of distance. Whereas the second mode of transmission is what's called the shared room air transmission. So this has attributed to most of the super spreader events in indoor spaces, where aerosols tend to accumulate over space and over time, especially in poorly ventilated spaces. So eventually, these aerosol scientists have defined, and epidemiologists have defined the risk of infection as a function of time. So the longer you are exposed to those viruses, the more likely you get infected. At the degree of localization, for example, if you're simply breathing, there hasn't been much what's called viral shedding that's happening. So you won't be introducing much viral copies in the air when compared to the other modular activities such as speaking, for example, or coughing, where you get to introduce more viral copies into the air. What matters also are the personal protective equipment such as masks, which we will be discussing later. And in terms of engineering controls, when separating the pathogens or reducing the concentration of pathogens, we rely on what's called the dilution. So the dilution can be further subdivided into three: ventilation, filtration, and disinfection of the upper room air. So what are the targets? How do we set the targets for the ventilation and filtration guidelines? So this is one of the study performed by a collaboration of epidemiologists, aerosol scientists, and public health experts, where they compiled most of the super spreader events, and somehow they defined a parameter that's called the risk parameter here. So this parameter is related to the duration of stay, the volume of the room, the ventilation rate, the protective layers that the people are wearing. So eventually they have derived this cumulative distribution function curve here. So CDF curve that resembles this. So we have a definitive relationship now on relating the parameters of the room. So what happens in the room and what is the subsequent risk of infection rate, which is also expressed as attack rate. So when imposing recommendations, we have to also define that there is a hierarchy of recommendations. So we have to start with the most efficient, of course, elimination, meaning you remove the source from, you actually remove the source of infection. So for example, the index cases, of course, there has to be constant monitoring. Of course, you won't be allowing symptomatic, for example, to enter establishments. There's also engineering controls, which I have previously mentioned, that have been separating the people from the pathogen. There's also administrative controls, and there's also personal protective equipment. And of course, on the last line of defense, we have those clinical measures such as vaccines, which improve our immunity against the virus. but it has we have to take note that this is a form, some sort of a form of a Swiss cheese model. So these 5 has to work together in order for the risk mitigation to work in the first place. If we mention elimination, so what is presented here are the graphs between, this is on the context of DepEd classrooms. So if there's a number of students within a room, if we're mentioning symptomatic transmissions, the number of infected also increases with the number of students. So basically that's the trend. But if we have to take note that if this poses the highest risk of infection, you have to eliminate these instances from happening. So if a person is coughing, you shouldn't allow that person from entering the establishment in order for the other 2 to govern, which are relatively lower. Of course, to address the other to address the other mechanisms of transmission, we have to rely on our engineering control. So we start with ventilation. But however, there's a key clarification that we should be making. First is on the air changes per hour. If we're mentioning air changes per hour only for CO2, it's the number of times that, if we're monitoring the CO2 levels, it's the number of times that the used air within the room is replaced with clean, fresh air. Whereas for SARS-CoV-2, the replacement can entail a filtered air. So if for CO2, for example, only clean, fresh air is the one replacing the used air within. But for dilution overall, it also includes filtered air along with the fresh air. So the factor of those 3, the sum of those 3 attributes to what's called the dilution. So the dilution here, for example, for not only for COVID-19 but also for other airborne diseases such as measles, COVID, and tuberculosis, you can actually reduce the probability of infection by diluting the exhaled air in the first place through these engineering controls. So for, of course, to monitor the CO2 levels, we should be employing CO2 monitor network. So this represents how fast the fresh air is being replaced by the indoor air. And this is one of the tools that I have handed over to DepEd on deciding, for example, if they wanted to introduce ventilation to the room, if for example, the atmospheric differences is not that high, so air changes are not enough. Parang the natural air changes are not enough to say that the room is well ventilated. We have to mechanically introduce the ventilation. So through the introduction of electric fans, for example, these are the specific steps on how, based on the CO2 levels, that you can derive the ventilation rate. So if you know the CO2 levels of outdoor air, if you know the CO2 levels of the indoor air, knowing the number of occupants within the room over a certain period of time, you can be, you also know the volume of the room, you can now derive the ventilation rate within that room. And it has been, CO2 levels has been used as a proxy for disinfection of COVID-19. This was already determined by Peng and Jimenez, and this was actually adopted in the PSMID guidelines. However, we have to take note that we have to be careful in purchasing CO2 monitors. There are no local suppliers in the Philippines yet, and there are many of the CO2 monitors that you're seeing in Lazada and Shopee are not actually CO2 monitors, but rather they count what's called the total volatile organic compounds. So to actually count the CO2 levels, you should be needing what's called the non-dispersive infrared sensors. And we're currently developing a locally produced sensor. As of now, hopefully we can mass distribute that in one of our extension projects. Also, this represents how, so of course, we have to present a picture on how ventilation matters in curbing the spread of COVID-19. So for example, if the inhabitants within the room is wearing surgical masks, so if the room is poorly ventilated, you would expect that the probability of infection is very high. But if you, for example, open the windows, there are some air changes happening. Somehow, the risk of infection reduces. And if you further ventilate that to the point that it satisfies the PSMID standards of 1,000 parts per million, you would notice that somehow the risk of infection flattens out. So again, one another benefit if we were to introduce, for example, exhaust fans or other forms of mechanical ventilation, is that it introduces what's called pressure diffusion. So in pressure diffusion, this is being employed in negative pressure rooms. The airborne pathogens that are floating in the air, once the exhaust fan is being turned on, most of them will be concentrated near that exhaust fan, therefore separating the pathogens from the inhabitants within. So instead of being uniformly distributed across the room, they'll be more concentrated near the exhaust fan. Another thing to consider, of course, are airflows. So since there are airflows within the room, we can assume that imperfect mixing happens. So CO2 is more diffusive than SARS-CoV-2 laden aerosols. Perhaps for regions, for instances or scenarios where there's dominant airflow regimes within the room, the CO2 levels may no longer be the proxy for CO2 rays. Since we're mentioning ventilation now, let's open the windows, let's open the doors. But for example, the windows are fixed, or the building managers cannot afford to even, or it's near impossibility to introduce ventilation into the room. The next thing that we can consider is perhaps we can opt for the filtration option. So for filtration, there are many options. Then apart from the commercial air purifiers, we can do what's called the Corsi-Rosenthal pack. So this is one of our ongoing projects where this is an DIY filtration device that is somehow efficient and economical at the same time. So this costs around 2,000 pesos. If MERV 13 filter is around 450 pesos. A box fan is around 2,000 pesos, or if you're going to use exhaust fan, for example, around 1,000 pesos, then you'll be duct taping them all together in this manner. And basically, we have been conducting many activities where we get to produce Corsi-Rosenthal box. What the Corsi-Rosenthal box does is that it sucks in used air within the room. It filters out the SARS-CoV-2 laden aerosols, then it pushes the air upward so that it breaks what's called the thermal stratification. So if there's thermal stratification, there hasn't been much mixing happening in the room. So there is this hot, stale air within the upper portions of the room. You wouldn't want that to happen. You have to ensure that dilution happens. And since we're mentioning upper room air, initially emissions are relatively hotter than the surrounding air, so therefore they float. We take advantage of the buoyant forces, and by the moment they arrive at the upper room sections or the upper sections of the room, we subject them to what's called ultraviolet germicidal irradiation. So we irradiate them to accelerate the deactivation of the virus. So meaning, if we deactivate the virus is no longer potent, or somehow the proteins within the viral copies are being destroyed. So that's what happens there. So that's what's called viral deactivation. And of course, we can still, this is the nuclear option, introducing HVAC into the indoor establishments. And the other, of course, after that, after engineering controls and elimination controls, we also detail some of the specific instructions on how people should act within these environments to further reduce the risk. So, for example, wearing masks, muffled speech. So we tend to speak louder in order to enunciate the words clearly. If you wanted to make the word across, however, that increases the rate of vocalization rate rather. You're introducing more viral copies into the air. So to mitigate that, you should perhaps equip everyone with microphones to address that risk. And of course, if we're mentioning sporadic emissions and asymptomatic transmissions, for example, since they are a function of distance, why not increase the distance to further reduce the risk? So this is why social distancing matters, and social distancing is often coupled with occupancy. So you shouldn't be putting many people, too many people in one space at one time. So to ensure that social distance happens. And of course, reducing the duration of stay matters. So when compared, if, for example, more than 9 hours of stay within the room, these are the sample probabilities of infection. If we reduce that from 9 hours to less than 3 hours, you can see that the probabilities of infection actually reduces. And same goes here. For example, if you're wearing masks, so surgical mask, for example, on longer durations of time. However, if you reduce the durations of time, you can see that the risk of infection has decreased tremendously. Of course, there has to be a preference to conduct activities such as outdoors, especially on activities that necessitates the removal of the mask, such as lunch, for example. If you're gonna dine out, do it al fresco, but still to address the sporadic emissions, enforce social distancing to reduce the risk that it causes. Finally, for personal protective equipment, as the last line of defense, we will be employing face masks. So not just simple face mask. It has to satisfy three criteria. It has to be a good filtering mask. It is a well-fit mask, and it is also a breathable mask. So among those criteria, the kinds of masks that satisfies these criteria are KF94 mask, KN95 mask, N95 mask, and even elastomeric respirators. So for masks, what the masks are actually doing is that just like a mesh, it is a series of mesh. So particles larger than the mesh size are actually captured in what's called inertial impaction. So parang nilambat mo siya, yung thing. For smaller particles like 0.1 microns, we take advantage of the Brownian motion and the van der Waals forces. So for those particles, the mass seems like a maze. However, their motion is somehow chaotic in nature. They tend to collide with one of the fibers sooner or after. And once they collide with that fiber, due to the van der Waals forces, they will be forever stuck there. So that's what's happened there. And finally, for the intermediate sizes, between 0.1 microns to 10 microns, we rely on the electrostatic properties of the fibers themselves. So the quality, it's not, this mass has to have that electrostatic properties in order for it to work in the first place. So how well does the electrostatic capture works is basically what defines the ratings of this mass. So for example, KN95 mass filters 95% of these intermediate these particles having these sizes. So it's for sure that you'll be capturing the larger sizes and the smaller sizes. So what matters is the intermediate sizes. So for mass, for example, for these three modes of transmission, so if there are no masks, you can see that somehow it is on the ceiling of the risk of infection. So you basically assume that there is a high risk of infection. But however, if you, for example, introduce face mask, for example, surgical mask, even though somehow ineffective, it introduces some level of protection, you can see that the risk somehow reduces. So same goes for here. So from these blue ones here, we go to the green ones, which represent the surgical mask. And once we go on to the higher, to the better masks, like KN95 mask, you can see that the risk of infection is has already reduced. So particularly for close range asymptomatic transmissions, it's almost zero for both instances for shared room air transmission. That's why mask matters. And actually, we have to fine-tune also the CO2 requirement. What the aerosol scientists like Professor Jimenez have been recommending is actually to further reduce the standard. Instead of 1,000 parts per million, perhaps we should impose a CO2 limit of 700 to 800 parts per million. And of course, this has to run across society. It should be a communal effort. It's not only a personal responsibility, but also a collective responsibility. So as one of the briefings of the White House that acknowledges the mechanisms of transmissions, let's clear the air with COVID. And not only on COVID, but also to other airborne diseases such as monkeypox, which alarmingly has been reported to, there has been already a reported case here in the Philippines. But of course, just like COVID-19, there has been a political intricacy. Somehow, they omitted the monkeypox virus from their previous manual on airborne transmission, so they removed that after June 22nd. But that's politics. But of course, we take note that perhaps what we're doing here can also help against monkeypox. And moving on, we have been doing workshops to enable, for example, practitioners to understand and actually simulate the mechanisms of transmission, and also to test some physical interventions. This was one of the previous lectures that I've delivered. I unfortunately hasn't managed to deliver the second part of the lecture, but of course, what this lecture entails is for some of the engineering controls, to control the relative humidity, evaporation rates, temperature, CO2 levels, and of course the airflows within the room. Hopefully, through series of the subsequent webinars of the UP Building Research Service, will be enabling professionals to understand and even model how to reduce or how to simulate these mechanisms of transmission. So these are the methods of analysis. So through concentration equation, for example, this box model, we could also do computational fluid dynamics and even Lagrangian particle, Lagrangian analysis, where you get to simulate those droplets, those aerosols being introduced in the air in the first place, where you get to track them as they travel across space. And we can also participate ourselves in disease modeling, because once we identify the risk, we would know for sure how we can address those things. And hopefully, we can talk about this in the future lectures. And that will be all so far. I thank you all for listening in this lecture.
Thank you, sir. All right, so now we'll move to some questions that are in our chat. So, sorry, nawala ko siya. Ito. All right. Do you recommend software, or what software do you use to simulate wind for beginners and intermediate level for students who want to study wind dynamic effects and to model different 3D shapes?
There are some user-friendly softwares. However, they are proprietary softwares. Like ANSYS, for example, they offer services in aiding researchers in simulating these phenomenons. But of course, if we want to get out of the proprietary ones, we can do the open source ones. What I'm currently using is what's called OpenFOAM. So, yun po, where you get to formulate even the equations and implement them in the simulation.
Okay, thank you, sir. Any follow-up questions from our participants or guests?
Siguro, Mumbel, while we're waiting for the other questions to come in, let me ask another question to Sir Josh. No? Sir Josh, so you mentioned 3 levels of controls that we can actually implement. No? So you mentioned yung pinakauna is ventilation, correct? But then kung hindi possible, kunyari server room na kailangang air condition, we can explore the use of mga filters. How much would it typically cost to install filters?
Depende po siya sa sa quality. So if you're mentioning quality of filter, what is recommended is to use MERV 13 to the very least po. So meron kasing MERV 14, 15, 16. However, the higher the rating po, mas mataas yung pressure resistance. So parang nagkakaroon ng strain dun sa air conditioning system po natin kung directly po siyang i-introduce. Pero yung pinakamataas po, definitely yung HEPA filters po. Pero yun yung nag-offer din ng pinakamataas na pressure resistance. So, pwede naman siyang gamitin. Again, na-mention ko naman po yung Corsi Rosenthal box. Pwede siyang gawin in that manner para hindi sa air conditioning system mapupunta yung strain.
Yeah, I'll follow up after, pero I think Sir Chicho has a question. Sir Chicho, go ahead.
No, I'm just curious, ano? Based on your assessment, is UP Diliman now adequately prepared for face-to-face classes?
Currently po, I've been aiding colleges po, and even in our institute po, we've been doing our best to implement those measures. And one of my assessments involves yung sa College of Fine Arts po. And I think College of Fine Arts has been proactive in doing yung mga airborne precautions in order to achieve yung to pursue yung pag-reduce ng risk. Hope we have ample time naman po, siguro 1 month will be enough to implement those measures, but meron naman po din nag-evaluate ng ad hoc committee po on that. So
yeah, because like my question, many of the classrooms now sa mga institutes sa College of Engineering are air conditioned, no, and there's no adequate ventilation. So I'm just curious how that is going to be addressed, ano? Anyway, that's just a comment.
yes po. Yun po, kung on some rooms, sinasuggest na buksan pa din yung bintana kahit na nakabukas yung air conditioning. So parang that puts strain sa air conditioning system, but that also enforces higher air change rate. So parang trade-off naman po siya. Yun yung some of the suggestions that have been floating on how to handle yung risk mitigation sa College of Engineering po.
Thank you.
Thank you, Sir Chicho. So, in the context of UP Diliman, Sir Josh, what would you recommend? Kunyari, so if yun nga, opening the windows is not possible for some of the classrooms because if you lift up the blinds and open the windows, hindi mo na mababasa yun na sa blackboard, sa whiteboard because of the glare.
Yeah.
No? So yeah, would you recommend yung, kasi may na-mention ka kanina na Corsi Rosenthal box?
Yes po.
And how much would that typically cost?
Corsi Rosenthal box po, depende po kasi siya sa sizes ng filters. There are 14-inch na filter, furnace filter po siya. So each costs around 150 pesos and you'll be procuring 4 of them. So 600 pesos. Then if you put a exhaust fan on top of it, so parang 2,000 pesos at least yung magagastos niyo po. Pero that offers around 385 cubic feet per minute na clean air delivery rate po. So in comparison sa mga commercial air filters, parang kalahati na nga ng presyo pero kasing efficient na niya. Ang next na lang po is determining how many Corsi Rosenthal box that are you putting in the room. Kasi po sa filters, meron pong tinatawag na safe distance po. Depende sa in-offer niya na clean air delivery rate, madedetermine niyo kung ano yung specific distance. So for example po, yung 300, yung around 356 na cubic feet per minute ng 14-inch na filter. So i-multiply mo ng 2/3 yun yung magiging mga around 213 na parts per minute. Basta mga around 200 square meter na area yung mako-cover niya po. So yun din po, yung parang in terms of noisiness po, kailangan din i-determine ko ano yung adequate na fan speed. Kaya nire-recommend ko din po yung exhaust fan kasi somehow siya yung mas tahimik compared kung box fan yung gagamitin na maririnig niyo po talaga ito.
Alright, for a classroom size that's approximately mga 50-60 square meters, how many of these boxes would be needed approximately?
If optimally placed po, actually, lumalabas minsan po 8 eh. Pero I would also recommend na kahit 4 lang will be enough. Kung filtration lang po yung magiging option po dun sa room.
Okay. Thank you. Baka nahihiya kasi magtanong yung iba eh. Kasi I am seeing names from, of course, mga staff natin from NEC are here. I see people from the QC Engineering Department. Meron tayo from NIA. Si Doc Fer has a question. Doc Fer?
Sir Josh, in terms of application, anong level, halimbawa sa classroom, ano yung recommended height na ilalagay mo yung box? Sa floor ba siya or at some height from the floor?
Based po kasi sa mga previous applications, okay lang po na kahit sa floor nakapatong yung box. As long as it's pointing upwards po. Kasi in that direction po, mas na-ensure po na yung mixing nangyayari dun sa.
Yeah, thank you.
Meron pa po ba tayo mga questions? Ayan, baka may questions from the NEC offices natin. I'm seeing quite a few familiar names dito. Si Ma'am Be Nice, si Ma'am Rhea. Si Ma'am Rhea ang ating outstanding reps for this year. Question po ba?
Sir, sorry.
Ayan,
Sir,
go ahead.
question po sa question box natin.
Yes.
So at your estimate, square meter per person is at ano yung estimate mong square meter per person na recommended for face-to-face classes or in office?
That's a very tricky question po na actually tinatakal din namin currently sa DepEd kasi merong limitation kasi it's a function of occupancy. Parang halimbawa yung 7x9 na classroom, ilan yung kaya mong pagkasya. Ang current na limit is 40 daw. Yun nga, parang kahit na sinabi ni Sara Duterte na walang limit, parang within DepEd, sinasabi nila na 40 yung limit. And that would have a social distancing of 1.1 meters. Pero again, ano po kasi siya. So in order to mitigate that, to work around dun sa limitations na yun, na hindi ko kasi pwedeng pakialaman, for example, yung occupancy. Kung talagang no choice na 40, ano yung pwede mong gawin na ibang measures? You would, of course, recommend yung paggamit ng high quality na mask to reduce, for example, yung duration of classes. So instead na 6 hours yung duration of classes, why not reduce that to 4 hours para malesen yung length of exposure mo? So ano po, magmamatter na kung may shortage dun sa sa isang measure, supposedly yung other measures yung magko-compensate dun sa shortcoming po iyon.
Okay, thank you, sir. Do you have any other questions po kaya from our participants?
Belle?
Yes, sir.
I'm sorry I'm in and out of the discussion, but if you're talking about thank you, Joshua, for what you presented. I didn't see it, but I'm sure you have studied it very well. One of the problems we always face is that if we approach the top national department like DepEd, mabagal lang takbo dun eh. But what others have done is they approach the local, the LGU. Sabi mo na lang yung school building ng barangay something sa UP. And what we have found is that these barangays have their own budgets. And they can do something directly in accordance with their budget. So what I'm saying is that I haven't heard the entire discussion, but if you are finding difficulty with DepEd, let's approach the local government. Actually, nangyari yan sa many of our members in ERDFI who had apps, etc. They spent so much time convincing DepEd, being given the runaround, but they found that the city division superintendent of the schools, they have the power. They have the power to procure all of these things. And yun, so it's really getting things done from the ground up. And this is something that we have seen replicated na kung national ang approach mo, it will take forever. But if you, what I call location is specific, the school itself, the PTA of that school, I'm sure they will gladly, hindi naman, hindi ako sure, but they might be more readily interested in getting things done. Anyway, that's just what I saw. I'm sorry I didn't see your presentation, but I'm sure you have studied it very well, Joseph. Thank you.
Yes po. Ayun po, to answer po yung concern niyo po about that. Actually, nagsimula po siyang grassroots movement. Parang recently lang po ako nagkaroon ng privilege na ma-bring up to the national government po.
So, bayaan mo na yung national.
Walang
mangyayari dyan.
May constraints po
yung
kasi.
Quezon City Division of the Schools.
Yes po. Meron po kasing constraints like, for example, kung memo, babangga po dun sa memo. So, yun po yung nagiging issue po minsan. Kaya, mabuti din na both ways po para...
Hindi, iwanan mo na yung national. Puntahan mo na yung local government.
Sige po.
I'm sure you will be happier doing that. But anyway.
Sir Tito, yeah, okay naman yung parang bibingka approach. So we approach from the top and from the bottom. And I'd like to acknowledge.
Wag na yung top. Sabi sa'yo, Harold, it will take forever.
Marami tayo ngayong participants from the QC Department of Building Official and Engineering Department dito sa ating webinar today. So ayan, narinig niyo si Sir Tito.
Yeah, I'm just sharing with you my experiences, my dear colleagues. But as I've said, we have seen results with the local government. And it's faster.
Sige po.
Thank you.
Thank you, Sir Tito. Are there other questions po from our attendees? Don't be shy. At this point, siguro we'll ask Ma'am Demi to promote yung ating mga participants para makapag-prepare tayo for the group photo. While we're doing that, Sir Josh, would you have additional insights that you wish to share considering yung discussion ngayong after your talk?
Yes po. Ano po parang in terms of kung paano ba natin i-frame yung mindset natin dito sa pandemyang ito. I understand po yung exasperation ng mga tao kasi yung for example sa face mask, parang ang dami yung sentiment somehow naglilin na dun sa disdain sa face mask and nagiging open na sila dun sa pagtatanggal ng face mask mandate. Somehow kasi yung naging connotation niya is aligned with the lockdown, with the compliance. Hindi lang po natin na i-communicate ng maayos kung ano yung na-offer niya na safety. So kung na-communicate po natin kung paano na-offer yung safety, knowing na that mitigates yung risk, so mahalaga din po talaga na i-mitigate yung risk. So yung magiging consciousness ngayon ng individual is not only for personal responsibility upon oneself, but personal responsibility to the community. Na by wearing yung face mask, for example, that's your individual contribution in curbing the spread of COVID-19. But the others, of course, yung engineering controls, sa atin po talaga nakasalalay as professionals. And kailangan po natin magtulong-tulong para matapos na po itong pandemya.
Thank you, Sir Josh. Yeah, Sir Josh, if they have other questions na nahihiya silang itanong ngayon, how could they possibly contact you or consult with you?
Yes, you can reach out po sa email ko po or ano naman din po sa social media accounts naman, parang madali naman din po ako ma-reach. Pero mas okay na email para kung nanghihingi po ng specific materials, may bigay po.
Thank you very much, Sir Josh. At this point, we'd like to present our certificate of appreciation. Let me just share the virtual certificate. And so I let Ma'am Bell present the certificate of appreciation.
All right. So, thank you po, Sir Josh, for your talk kanina. No? So we would like to give you the certificate of appreciation for your valuable contribution as a speaker on the topic of engineering measures for minimizing COVID-19 transmissions in buildings, part of the Safe, Resilient, and Sustainable Buildings webinar series, given this 30th day of July 2022 via Zoom. So thank you, sir, for being our first webinar, being part of the first, being the first presenter in the webinar series. Thank you, sir.
Thank you po.
Okay, sir. At this point, sir, na-move na ba yung attendees?
Yeah.
Hello, ma'am.
Habang-
I'm moving everyone, pero medyo
okay.
natatagalan po.
Okay.
Mga 2 to 3 minutes, ma'am. Thanks.
Sige po.
So siguro ay habang hinihintay natin yung pag-move ng mga attendees, no, I just wish to express my gratitude to everyone who made this event possible. Let's start with people who were who worked in the background, no. So si Ma'am Demi, napakasipag nating research associate. Si Ma'am Billy and si Sir Louie, and sa ating masisipag na BRS staff. We also wish to give our heartfelt gratitude gratitude kay Ma'am Bell, no? Si Ma'am Bell, when we asked her to MC this event, tinanggap niya yung heartbeat. Salamat, Ma'am Bell. And thank you, Sir Joshua, for being our distinguished speaker for today's session. I wish to emphasize to everyone that this is just the beginning of our Safe, Resilient, and Sustainable Buildings webinar series. Also, every month we will hold this. We just have to finalize the lineup of the speakers, but should you wish to be in the loop for the upcoming webinars, just visit our Facebook page. Let me just paste yung i-like nyo na rin yung Facebook page ng UPBRS. Yan. So you could constantly be in the loop for our activities and events. Yeah, thank you sa ating mga distinguished guests from UP Earth, Sir Chicho and Sir Tito, our former directors of UP BRS, Sir Fer, Prof. June, and Sir Jola, Sir Boji. Acknowledge din natin nandito ang head ng ating Environmental and Energy Engineering Group of the UP Institute of Civil Engineering, si Ma'am Lea Jola. Hello, Ma'am Lea. And thank you sa ating mga supportive na staff from UPNEC. Nandito si Ma'am Binay, si Ma'am Rhea, si Ma'am Pat. I'm not sure kung sino pa iba. Pero thank you pala kay Sir Janjan who made the video for us, the Paglingon video. Thank you to our attendees from the Quezon City Government, from PICQC, at sa mga iba pang dumalo. So salamat. We wish to see you in future in the future activities of BRS, and should you have needs for expertise on building science, engineering, and construction, do not hesitate to contact us, no? Ayan, so nakita nyo yung expertise that we can provide in building indoor air quality and aerosol transmission prevention. And I've showed to you yung mga expertise ng ating mga fellows. So, ayun po. Meron pa tayo.
Harold, do you have a publication material about BRS that we can share with others?
Yes, sir. I will share my presentation that I shared earlier.
Please carve it out and give it to me, and we can help in making sure that everybody knows BRS. Thank you, Harold.
Thank you very much, Sir Tito. Okay, so mag-practice na muna kayo ng mga smiles nyo para pag nakalipat tayo lahat to panelists, no? Ready nang ngumiti lahat.
Or pwede ngayon i-check na nila if nag-work yung kanilang cam. Diba? While we wait.
Oh, I also wish to acknowledge pala si Engineer Alfred Amaloria from the National Irrigation Administration, also a board member of PIC Quezon City. He's here today.
Very good.
Salamat po sa lahat ng mga dumalo.
At huwag mong kalimutan yung training programs natin, Harold.
Yes po, sir.
Yung ginawa mo sa whole sim, you do it in BRS, please.
Yes, sir. Yes, sir. Let's start with the konti na lang. Gallery view.
Wow.
Okay, sa mga na-promote na po to panelists, can we just check if you can turn on your cameras and practice natin mga smiles natin. Nakalimutan ko i-acknowledge si Ma'am Jessica Mandy, live from Auckland.
Oh, talaga.
She also was one of the project associates ng UP Building Research Service and now fellow alumnus of the University of Auckland. Hello, Ma'am Jess.
Hi, Sir H. Just to provide added truth po, nasa Philippines po ako right now, but
nakabalik ka na pala.
The University of Auckland sa September po sana. Congratulations po sa event.
Thank you, Ma'am Jess. Okay. Nakabalik na pala si Ma'am Jess, so graduate na siya. Congratulations. We're waiting for 6 more. Hindi namin matulungan si Ma'am Demi. Apparently, only the host is able to successfully promote to panelists.
Apologies also, sir. I'm clicking like 10 times for them to be promoted.
Medyo ganun nga. May glitch tayo sa ating Zoom posting.
Gamitin na lang yung UP system na no fail para ma-promote lahat.
Yes, sir.
Wala po sila ngayon kasi wala tayong support from Computer Center today kasi non-working non-working day.
Okay. And I will just keep on smiling or
yes talking? Po. So practice lang ngayon talaga pag nasa as pag celebrity kailangan
So when is Jessica coming back to UP? Kailan ka matatapos, Jessica?
Hi sir, matatapos po ko by September 28.
2022?
And hopefully I can be in UP if ever provided the opportunity as a lecturer. Nag-apply po ako.
Talaga, what do you mean if ever provided the opportunity? Hindi ba automatic na balik ka sa UP?
I'm actually a scholar po from the government.
NEDA. She works in the NEDA now.
Oh, talaga. So you are different from Harold.
Different, yes, sir. Maybe,
I
sir,
mean, different in terms of funding, but the same in terms of intellectual skill.
Yeah, that would be a positive comment about me. Na master's degree po yung accomplishment ko po recently.
especially yung mga iniwanan mo nung umalis ka, dapat you revive them. Just like what Harold did with the Holcim.
Looking forward po.
Namatay nung wala siya eh. Uy, okay na ba yung first sem, Harold?
Yes, sir. There was a change in the management din sa Holcim, pero okay naman po.
Tuloy pa rin. Good. Oh, sayang kung mamamatay ulit yun. Sayang yung mga pinaghirapan natin.
We just wish for the participants to hang on, konti na lang. Let me again try to help Ma'am Demi in promoting participants to panelists. Okay, sa mga ano na po ngayon, can everyone turn on their cameras and I'll take a sample photo. Okay, 1, 2, 3, smile. Isa po, 1, 2, 3, smile. Yung iba po, sana may camera, if you can turn on your cameras. Ba't yung iba bumabalik sa panelist? Bumabalik sa ano?
Attendees.
Okay.
Thank you.
Sige. Ma'am Demi, baka ano na lang, okay na tayo muna sa ngayon. Let's take the formal photo. Okay. At the count, I'll count 10 po para mahintay natin lahat na nagtuturn on their cameras. Tapos after that, we'll count 3 to take the photo. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3, smile. Okay, thank you everyone.
Thank you, Harold.
Thank you, everyone.
Salamat po sa ating lahat.
Please email to me the group picture para isama natin sa in the loop natin.
Thank you po. Yes po, will do po. Sir.
Para may isama sa in the loop. Thank you. Have a great day, everybody.
Thank you, Harold.
Yeah.
Thank you everyone.
Doc Aquino, are we going to register pa ba sa succeeding webinars or are we automatically registered na?
Automatic registration naman po. We just need to get your emails registered for every webinar. Pero hindi po kailangan ng approval. So, and standby po for announcements on the schedule. Kasi ina-arrange po namin na may PRC CPD points. So kaya medyo natatagalan kami maglabas ng mga details. Thank you po. And thank you, Demi, Ma'am Bell, Ma'am Billy,